bringing forward massive projects to produce, distribute, and use hydrogen. The Hydrogen Council is tracking over 300 billion of hydrogen energy projects between now and 2030, which is up 60% in 1 year and shows no signs of slowing, including recent announcements here in Canada. Hydrogen can be used to decarbonize challenging, hard to decarbonize sectors such as industrial processing, heating, and transportation. And the combination of batteries and fuel cells can achieve electrification of all types of transportation, from light and heavy duty, ground, marine, and air transportation, including applications where productivity is a priority in terms of payload, range, route, and driver efficiency. So here in Canada, the federal government has developed and is preparing for implementation of the hydrogen strategy for Canada, with 32 recommendations of actions to ensure Canada fully benefits from hydrogen energy. And this is backed with supportive policy such as the Clean Fuel Standard and unprecedented funding. The $1.5 billion Clean Fuel Fund, $2.75 billion Zero Emission Bus Program, the $8 billion Strategic Innovation Fund, all of which can be applied to hydrogen energy. The Ontario government is in the midst of a consultation process to develop a hydrogen strategy with the goal of making Ontario the best place to demonstrate and deploy hydrogen energy applications. And municipalities, ports, and industrial centers are jockeying to become hydrogen hubs. It's all very exciting. But what does it mean for Ontario transit agencies? Fuel cell electric buses are the most advanced of the heavy-duty fuel cell applications. So should Ontario transit agencies evaluate fuel cell buses as part of their transition to zero-emission vehicles? So my high-level question for the panel today: are fuel cell electric buses a viable choice today? And should they be part of the mix to allow Ontario transit agencies to fully transition their fleets to zero emission? To address that, I have a series of questions to ask our distinguished panel today, and I'll encourage the panelists to more fully introduce themselves when they speak. But briefly, the panel consists of Pietro de Zanno, who's in charge of business development for hydrogen with Stantec Consulting; David Zekveld, who's director of hydrogen business development with Altura Power, a subsidiary of OPG; Thomas Small, director of new product development with New Flyer; and Reb Guthrie, principal with Fuel Solutions Incorporated. So we have a lot of ground to cover, but I'll get right into it. Well, by turning first to Thomas with New Flyer to just please give us a description of fuel cell electric buses, you know, the ballpark costs, their cost trends, how they perform, et cetera. And I'll turn it over to you. Thanks very much.
Hi there, Thomas Small, Director, New Product Development. Nice to see everybody today. I've been with New Flyer for coming up on 21 years now. I've seen lots of changes in propulsion, very exciting things that have happened from conventional diesel and CNG through hybrids, battery electric, and fuel cells, as we've dabbled in for since the 90s. So just to get going here, so what really is a hydrogen fuel cell bus? It's really just an electric bus, but it's got a small amount of batteries. So it's really no different than our current offering of battery electric buses. So it's the same propulsion, same type of batteries, however, a smaller amount. One of the key things is that what the fuel cell does is to, in order to get that extra range that, you know, where the batteries fall short, and the charge time versus fill time. Really, you may remember grade 8 chemistry where you converted, you know, hydrogen and oxygen into water. Really, you've got to collect a couple of electrons, and you can use those to power or provide power for batteries and propulsion. So briefly, you know, you can go on the internet and get all sorts of details here, but essentially, you're taking that hydrogen and splitting it to basically stripping those electrons off, and you have a positively charged ion that again combines with the oxygen through a proton exchange membranes and what you may hear of membrane electrode assemblies. So all really good stuff here. And then you collect that electricity, and really you're only producing water. A little more complicated than that is how does that turn into a bus? Well, you have all these other subsystems that go along with that are called balance of plant. What's not shown is air intake systems, exhaust systems, and you know, there's actually quite a large radiator that's required. So really, that's what comes down to it. When you talk about cost, well, wow, what does that mean for cost? Sounds complicated as I state here. And in Canadian dollars, you know, battery bus could be a little over $1 million. Well, we're looking at today's prices, kind of an upcharge of around in the 400,000 plus, and again, Canadian dollars. So that's where that is today. But things are coming down. I got to tell you that. We expect price reductions with higher volumes. If the trucks start to gain interest there, we can see reductions there. And once you have those economies of scale, then the supply chain is more mature. You have process improvements. You have competition, automation of production, so you can drive those costs down. And as there's more competition, that just naturally drives costs down in terms of fuel cell providers. And then all the non-recurring engineering is paid, so that becomes also a cost driver as well. One of the things is, this goes back to 2012, but the U.S. Department of Energy targeted at $600,000 for a fuel cell bus, which is around 780 Canadian today. So prices are expected to mature to get down to basically what a hybrid would cost today. So that's where we expect those to go, and those trends and costs. Again, going back to the electric bus and the benefits of those versus a conventional internal combustion engine with the high efficiency, quiet, low vibration, low maintenance, and those long life components. And again, one of the key benefits though is that longer range on a single fill, and the fill times. Really, the fill times are in the 12 minutes versus 3 to 4 hours. Really, that's kind of from a bus perspective how we see that emerging.
Thanks, Thomas. That gives a good overview of things. So what I'd like to do now is talk with the whole panel and ask everybody here now, what benefits do you see that a fuel cell electric bus might offer a transit agency, and basically why should they be considered? And I'll start, I guess, with Stantec, with Pietro Zanno.
Well, as you mentioned, hello everybody. Sorry. Well, I'm the subject matter expert on hydrogen for Stantec. I also do some business development, and some of the things we're seeing is how do companies, or how do utilities, or how do municipalities meet the CO2 emission limits that are being imposed, or how do they meet their own requirements to be as green as they wish? And at Stantec, we break it down into engineering services that we can provide all along the value chain of hydrogen supply. So when you're looking at the bus, it only works if it has this robust system behind it that is supplying it hydrogen. And we have to understand the component parts of all of that. Reb will give us a bit, maybe information on the fueling station, but how do we get hydrogen from that fueling station and into the fueling station? And so Stantec helps out in making sure that you have the right electricity, that you have the right technology, that you have the right compression systems, the right distribution systems, all in a way that is presented and very safely. So from our point of view, we look at these things very holistically. And if we are going forwards with these types of buses, and I'm a proponent of that because I think it absolutely has to work, then Stantec can help all along that value chain to get the best value, the best made decisions for whomever, for whatever criteria they're using. So that's how I think we can help, and that's how I think we should help.
Thanks. And David, how about you? What do you think? What benefits do the fuel cell buses offer to the transit agencies, and why should they consider them?
Thanks, Mark, and good afternoon, everyone. I think the groundswell movement for hydrogen in Canada and Ontario right now is a great reason to consider hydrogen fuel cell electric bus. In particular, where we can co-locate other uses of hydrogen, industrial demand, and supply in something we call a hydrogen hub. So the hydrogen economy and ecosystem, if you will, is likely to take off through these hydrogen hubs. And if you've got an anchor customer that can give that significant demand for hydrogen, you can then economically produce clean hydrogen and use some of that clean hydrogen to help the transition to a fuel cell electric bus. So like Pietro, we're looking at more downstream. Where does the hydrogen come from? How is it clean? Where are the opportunities to produce it? And right now, with the support that we see on the zero emission bus program, the clean fuel from Enercan, 1.5 billion for a minimum of 10 clean hydrogen projects across the country. We see a great opportunity to leverage those hydrogen hubs and for interested transit agencies to put their hand up and say, be it Ottawa, Toronto, Niagara, wherever you are, if you have an interest in hydrogen fuel cell, let the hydrogen community know, because we're starting to see that movement towards hydrogen hubs, and understanding that demand and opportunity, I think, is really the benefit that we see today.
Thanks, David. And Red, yourself, how do you feel about this?
Well, in terms of how hydrogen buses how they would apply, I think really the big takeaway mentioned early in the talk is footprint and the conciseness of the lack thereof of the footprint. If you're comparing it to the other more typically thought of zero emission bus of an electric buses take a fantastic amount of infrastructure at the depot, from large utility interconnects, gantries and overhead charging infrastructure, charging power, probably absorbing a lot of and restriping of parking garages and yards, because the infrastructure is vast and it affects the entire extent of the bus facility. Conversely, with a hydrogen facility, the hydrogen system can be compacted and located in a kind of a sequestered area of the facility, and the existing bus operations, the bus circulation, bus processing, cleaning, fueling operations, etc., can be carried on with essentially no change. While the fueling does take a little bit longer than it does for diesel or even CNG fueling, at somewhere around 10 minutes to load a 30 kilogram payload, because the other processes for fare retrieval, cleaning, interior, exterior cleaning, etc., take that same approximate 10 minutes, you're really not extending the overall bus processing time. So hydrogen is a great opportunity to employ zero emission technology while still preserving the existing bus operations, vehicle circulation, and it does take some room. I mean, clearly there's got to be some space assignment for the hydrogen system at the facility, but it can be segregated and made to be concise, as opposed to a battery electric system that, to use a bit of a pejorative, sort of litters the entire yard with infrastructure. And so I think that's something that might be quite attractive to agencies and not have to turn their yards upside down.
That's good. And now back to Thomas. I mean, you're the one selling them. What do you think? What are the reasons why a transit agency might want to consider fuel cell electric buses?
Well, obviously the impact on the environment and that sort of thing, and probably get into the types of hydrogen production later. But certainly on the electric vehicle, as I mentioned, benefits are with just being electric, the high efficiency, the quiet, low vibration, low maintenance. For example, or the motor we use is it's got a 20-year life before, or even upwards of that. The bearing replacement beyond the normal life of the bus, and just really greasing of that bearing is all that's required there. You don't have any oil changes, coolant changes. Coolants are running at lower temperatures, last longer, that sort of thing. But one of the key things is that range on a single charge. We can regularly get in the 250 plus miles range. So equate that to kilometers is quite good. One of the other things is that 10 to 12 minute fill from a full empty to full. So versus 3 to 4 hours for charging. So there's that benefit associated with that. So right now it's really that hurdle is the capital cost. And once we've gotten that volume down, our volume up, so they drive that price down, then we can start to see some more adoption here. And then it's about that supply chain of the hydrogen itself. So that's really kind of the crux of it from that perspective. Obviously, we want to get to zero emission, and the best way to do that is through through electric with battery electric and fuel cell buses.
Thanks. One of the things I've heard and people talking about is resilience. And I mean, coming out of the COVID crisis, well, hopefully coming out of the COVID crisis, it's highlighted the need for resilience in our systems to be able to respond to changes and upsets and continue to service customers. Do you see a mix of fuel cells and batteries helping in the resilience end of it? I'll open that to anybody.
I do. I think it's a mix. You'll see a mixed fleet probably for some time to come. I don't know that you'd have one or the other in the end once all internal combustion engines are no longer required. The gone with the typewriter, so to speak. So yeah, you'll see a mix depending on the operation of the system. So there's lots of participants, and listeners here that have got all sorts of knowledge and that with lots of varying degrees of experience and trying to sort out these types of operational issues and challenges where they have a fleet of CNG or diesel electric today, and how do they make that transition?
I'd second that, Thomas, in terms of, we see multiple or both technologies being a part of the future for zero emission buses. And the parent company of Altura Power is Ontario Power Generation. In Ontario, we have an exceptionally clean electricity grid, and OPG is working with the TTC to electrify their fleet in part. So battery electric we see as being a part of the solution, but there are certain applications where fuel cell electric we think has a great opportunity as well. And so we want to help and be a catalyst by provision of that low cost, low carbon hydrogen.
All right, that's all very well, but are they safe? Let me turn that.
May I
go ahead.
Provide a bit more information on resiliency and robustness, Mark?
Go for it.
Okay, thank you. I think Ontario is in a very, very good position, better than most other provinces, in terms of also having a very robust, potentially a very robust hydrogen supply, which is very important to all the potential users of the hydrogen. They're going to say, well, how am I going to get it? And if it fails, what are the backup systems? And Ontario has already liquid hydrogen supply production in Sarnia, but around it, there are other companies in New York and also in province of Quebec that can supply liquid hydrogen more so than any other province, actually. It's kind of interesting when you look at it that they have so much potential liquid hydrogen supply. And when we're helping customers look at their value chain, we are helping them not only from a technical supply, okay, you can get it from these people in this way for this application, and this is what it's going to give you. But we also, and then we can also look at the backup systems, but we also look at it from a point of view of helping from a commercial point of view. How do you not want to break contracts, but how do you complement or supply contracts so that you're always supplied with hydrogen if something goes wrong? At the moment, hydrogen is not yet the fungible product that diesel or gasoline is, but Ontario, being in the position it is, can start exploiting that attribute, that leverage, and doing better than other places. So just wanted to highlight that the value chain needs to be as resilient as the trucks or the buses.
Okay. And I'll go back and still hold you to that. My original question, though, are they safe? Will the public accept them?
Are you asking me now first?
Sure, go for it.
Hydrogen is not what people have been perceiving it to be. It is quite safe. It's been handled by the refineries and the industrial companies for whatever processes they've been doing now for hundreds of years, 100 years at least, let's say. And you know, the standards are being met at an industrial level. Now we have to bring those standards at a more retail level, or at the level where the buses can be used by the municipalities, but that's all going to happen. And we understand the molecule. It is easily managed. It is as safe as it can be. I don't think that we need to worry about that.
New Flyer, have you had any experiences? How's the acceptance of hydrogen buses been, David or Thomas, in terms of the public's acceptance of them?
Well, I think it's been very good. We've had, I would equate this to the safety of you know, as CNG as well, which is quite mature here. We started delivering CNGs in early 90s. So one of the things I'm showing here, you know, you got fire detection, shut off high voltage, you know, other things that happen, you know, pressure relief devices activated, venting to atmosphere, you know, all the things surrounding the hydrogen itself, you know, tank temperature reporting to fill stations for that. And here's some images of exactly where these types of you know, components are. And really, this is typical of the CNG. So we're just bridging the gap from a different fuel source, from CNG to hydrogen, and we manage that well. We've got the latest configuration of fuel cell. It's a Ballard fuel cell. We delivered 25 in 2018, and we've got more orders. So the acceptance is there, and the AC Transit just placed an order for another 20. They're in Oakland, California. So quite popular there, and we're starting to see some interest. You know, there's some around the Chicago area. But the Northeast is starting to develop some interest there. So we do actually see a Northeast US, that is. So we're starting to see more acceptance, more acceptance. Basically, it's about maintenance techs and being given that technology in order to service these. So develop the workforce is also extremely important. So they gain comfort in being able to service these vehicles. High voltage training is required for even down to a hybrid that we've been delivering for quite some time, but the battery electric as well, it's just dealing with more of it. Really, it's about the tools, the training, and that would gain acceptance at the property level. Okay. So I think we're, you know, we're quite well on the way.
Right. And so that's all very well in terms of the, you know, the safety, the public acceptance, but, you know, is it achieving the main goal? Are they clean? Do they achieve the GHG reductions, the zero emissions performance that we're looking for? I'll turn to David for that one.
Yeah, thanks, Mark. So, you know, a fuel cell electric bus is as clean as the hydrogen that powers it. And at a very high level, hydrogen is generally color coded into three main categories. The status quo would be gray hydrogen. And gray hydrogen is produced from steam methane reformation of natural gas, which has emissions. The next cleanest would be blue hydrogen, where you use that steam methane reformation of natural gas, but then you use carbon capture and store or utilize that carbon, reducing the emissions from that hydrogen production process. And then lastly, you've got what's coined green hydrogen, where you use renewable or zero emitting electricity through a process called electrolysis, where you separate water, H2O, into its constituent hydrogen and oxygen molecules. So Canada and Ontario have kind of taken the stance of not having colors, but rather calling hydrogen low carbon, and saying, you know, there's a threshold for your intensity of that hydrogen that you must be below to be considered low carbon. And so if you're using low carbon hydrogen, you're having a significant net benefit. And to the extent that you can get to that zero emissions hydrogen, be it green or, you know, as blue technology improves, you know, you're going to have that net zero impact. And I'm going to share a few slides about OPG and how we think that OPG and Altura Power can support getting to that net zero production. So first off, just for context, because I'm talking about Altura Power and Ontario Power Generation, folks on this call are probably familiar with OPG, generate half the power in the province, but we've got some subsidiaries to OPG. Laurentis, a consulting company, Altura Power, which is where our hydrogen business lives, Eagle Creek Renewables in the US, and personal vehicle charging network called Ivy. So again, we produce about half the power in the province. We're owned by the province of Ontario. And this is our asset distribution. And I like this slide because it shows you the types of assets that OPG operates and the opportunity that we have to generate that clean hydrogen from clean input sources of electricity. So if we look at the province of Ontario, within Ontario, we've got 2 nuclear stations that OPG operates, 2 that we lease, 2 thermal stations, 1 solar, an incredible 66 hydroelectric facilities which are distributed around the province. And then into the US, we've got 86 more hydro facilities, and then 4 CCGTs, or combined cycle gas turbine plants, which burn natural gas. So part of the reason we're looking at using Altura Power for our hydrogen business is we can decarbonize some of our natural gas use by blending in hydrogen. So that's the connection there. But you know what OPG has done, and what you'll see in the province, is we have no coal. In 2014, we shut down 9,000 megawatts of coal, which is actually one of the biggest climate change actions taken to date in the world. 9,000 megawatts is about a quarter of the production in Ontario. So the resulting grid that we've got in Ontario is exceptionally clean, which is great for electrification, but also if you're producing your hydrogen from this grid or using these assets, we're going to have very clean hydrogen. And again, the opportunity that we see is with these distributed assets around the province, we're looking at hydrogen hubs and how we can help be a catalyst towards hydrogen hubs throughout Ontario, where we would leverage these clean energy assets, co-locate with large industrial consumers of hydrogen, and use that clean hydrogen to support offtake for transit agencies, local transit agencies. And where we want to get to is low cost, low carbon hydrogen or green hydrogen. And when you look at projections of the cost of hydrogen, it's continuing to come down as the cost of electrolyzers continues to reduce and technology continues to progress. So in summary, and answer to your question, Mark, the hydrogen used in the fuel cell electric bus is what determines how clean it is, and you can get to net zero. We see a great opportunity with the electricity infrastructure in the province.
That's great. And so to summarize, there's certainly no reason why somebody can't get clean hydrogen to supply their buses. And Pietro, can you add to that? I mean, that's OPG. Is there other sources of clean hydrogen that Ontarians can take advantage of?
If they wish, they can always look at using, as it was mentioned, blue hydrogen. It is possible to do that in the province. That does have some of the geology where it can store the CO2. Some of the liquid hydrogen that can come from New York as well is also powered, I believe, from hydropower. So yes, and from Quebec as well. So yes, hydrogen is available that is clean that can come into Ontario. Yeah. So they could produce it themselves through OPG. They could produce it themselves with natural gas and some geology, or they can import it. And most of it is clean that can be imported.
I will also point out that there's a potential to make clean hydrogen from biomass as well. And there's a number of companies in Ontario that are working on.
Oh, yes. I do believe it's a bit costlier. That's why I didn't bring it up.
All right, so that's talking about now that you can get the clean hydrogen. Now talking about the fleet again, what's the impact on sort of maintenance and service? This was touched on a little bit by Thomas, but I'd just like to hear a little bit more about what a facility would need to do, what they need to think about in terms of maintenance and operations. So I'll start with Thomas and then move on to Reb to answer that question, if that's okay.
Sure, Mark. As mentioned, to integrate that into the fleet from service and maintenance standpoint, the electric stuff is the same. It is a battery electric bus, small amount of batteries, as I stated. You just now have to deal. So if you already have that in place, you already have battery electric buses, then there's really no difference in terms of that. You should be knowledgeable there already. If you don't, then you have to learn that part of it. You're going straight to fuel cells. But the difference is on that fuel cell itself. You have CNG already in your facility, then you're familiar with the CNG tanks and storage systems there on the vehicle. So they're very similar. So it's a matter of getting that maintenance training to support the vehicles. Again, you don't have oil changes. You don't have, coolant, multiple coolant flushes and no transmissions to rebuild or oil changes on them. As I stated, motors are long life, require little maintenance there. Where you get into the details here is on that fuel cell itself. Certainly you'll have air filter changes. That's required there. It's on the fuel cells itself. The balance of plant, there still might be some maintenance associated with that. But we haven't had really good, solid, long-term, at least the more mature fuel cells we've been releasing now, to get a really good feel for what kind of pitfalls there are. From the perspective of the stack itself, it's really a 5 to 6 year life on the stack. So you're expecting a midlife on the fuel cell stack itself. Again, not completely known as we're not far enough along in there, but some early results or some results of the trials that Ballard has had in a couple locations in the US has shown really good life there, but they're still maintaining. You basically lose about 10% of the capacity at the end of life. So that's what they call end of life. So on an 85 kilowatt fuel cell, you're going to be down to like 76.5 kilowatts available. And incidentally, you may not even realize it on your conventional diesel or CNG. It's losing power as it ages too, with wear, et cetera. It just consumes more fuel to get to those power levels. From the fuel cell standpoint, it's really a power loss over that time, and it's about time to replace it at that point. So again, that's really what it comes down to. So it's about making sure your facility is equipped and your technicians are trained in order to service them.
Brad, do you want to add anything to that?
Well, sure, and we got a little bit starting at the end. I do have some comments I wanted to make just about the general choices of infrastructure, but I think the key point that I would make about facility infrastructure-based maintenance at the site is that certainly the agency is welcome to and may elect to self-perform that maintenance. But again, going back to the analogy that Thomas has made about CNG, that most CNG facilities, they're somewhat technical, and hydrogen facilities are even more technical than that. So the agencies will typically elect to hire that out and concentrate their efforts on moving people, and not necessarily get into the business of self-performing maintenance work. So I think for any specialty technical work, developing procurement practice for qualified maintenance services is very important. That's not to say that local staff, on-site staff is going to be completely sort of ignorant to the facility. Conversely, understanding of how it works, some basic maintenance, some basic troubleshooting, et cetera, is important. But I suspect that most agencies would choose to offload and contract out for the maintenance of their infrastructure by qualified personnel, and that can be done on a time and materials type basis, or it can be done on a per unit of fuel delivered basis. So there's different commercial models on how that can be done. It can be included with the overall development of the facility. It can be contracted separately from the facility as a standalone service. There's, and there's also varying degrees of local participation and local, we've seen models where the project starts out with a high degree of responsibility by the maintenance contractor, the third-party maintenance contractor. And then as time goes on, the agency becomes more familiar and comfortable with the technology. And these are obviously smart technicians that are working at the facilities for the agencies, and they may elect to slowly over time absorb more of the day-to-day responsibilities for maintenance. So there's all kinds of different models, but I think certainly starting out with outside assistance and qualified personnel is certainly important to a successful infrastructure program.
Okay. And while I've got you, can you just go and describe a little bit about what a fueling process looks like for them? You mentioned sort of 10 minutes, but can you just describe what the dispensers look like, what the fueling process is, how it compares to other types of fueling?
Yeah, certainly, Mark. So, and I do have a few comments on that. And before I kind of go into my brief monologue here, I did want to acknowledge again Stantec that we are a long-term partner with. We've provided fuel system design, consulting, and engineering to Stantec for more than 21 years. So we're really glad to be part of their team, and we appreciate being here. But so, on that, in terms of the infrastructure and the fixed site assets related to vehicle fueling, there are different ways to do it. And I want to start by illuminating, let me do my screen. I haven't shared a screen yet, so I'll do that now. Let's see, here we go. So let's start with the liquefied solution, which is certainly the most common. This is a facility in Orange County, California, at Orange County Transportation Authority at their Santa Ana facility. And what you're looking at is an 18,000 gallon cryogenic tank. At the far end, not in this picture view, are two reciprocating piston liquid pumps. Heat exchangers here warm the pressurized liquid to ambient temperature. And then it's routed sort of in front of the pickup truck here over to the fueling building, which is off-frame to the right and below. And it provides fuel to two service lanes. And this is initially designed to fuel 10 pilot vehicles, but it's really capable of fueling about 50 at the time that they get up to 50 fuel cell buses that'll have inadequate capacity. But let me just walk through while you're looking at that. I'll sort of describe, Mark, as you asked what's going on here. So bringing in liquefied hydrogen, cryogenic tank, as I mentioned, it's stored at relatively low pressure, about in the range of 100 psi, but very cold. We're talking minus 250 C, so it's near absolute zero. And the pumping brings it up to 400 bar. We're in the range of very, very high pressures for maximizing the density on the bus. I mentioned there's heat exchangers that warm it from a high pressure liquid to a high pressure gas. And we can, with the high pressure pumping that is moving the product, we can deliver and dispense 30 kilograms, which is a typical full fuel load for a bus in the range of 10 minutes. That's a realistic approach. And by simply, and especially in a liquefied system, by just adding more parallel pumps and heat exchangers and dispensers, you can do 2 and 3 and even four lanes at a time and treat it the same way you would a diesel or CNG processing system. And fuel buses, and as I mentioned earlier on, very much in a transparent way to the way buses are fueled currently in with the diesel model. You can also deliver with gas. It is certainly technically possible. The problem with delivering as a gas is that the density is very, very poor compared to a liquid. We're talking on the range of 10 to 1. So you know, for a volume of a kilogram of liquid hydrogen, you would need almost, you'd need about 9.5 times that same volume to contain that same kilogram of gaseous hydrogen. And that's at 250 bar, which is the transport pressure. So even at relatively high pressure, it has very poor density characteristics compared to a liquid. So, you know, gas tube trailer transport works okay for very small projects, pilot projects, and smaller retail applications. But you soon are, you know, trading trailers all over the place, and it's not a good model for larger applications like a full transit application. So if you're not going to truck it in, whether it's liquid or gas, then the other approach is you can grow it your own on site, and you can do that with two basic ways. It's been alluded to in some of the other comments. The first and more typical on-site production approach being the steam methane reformer, applying high pressure, high temperature steam to natural gas typically, and breaking it down into hydrogen gas, and then you've got effluents of carbon monoxide and CO2. That gas comes off at about 200 psi, and then it has to be further compressed back up to that same 400 bar target pressure that I mentioned earlier. You know, we're talking about 6,000 psi, so it's a relatively high pressure, and again trying to get that high density on as a storage medium on the bus. One thing that's really interesting and is something that's very notable for properties or programs that are considering on-site production, either from SMR or electrolysis, is that the systems want to run 24 hours a day. Their production rates are relatively modest, you know, relatively speaking. So to be effective, they need to continually be producing hydrogen. But you're only fueling buses roughly 8 hours out of the day. So that means 16 hours out of the day, you're producing hydrogen and are not fueling it. So you need to accumulate it and sequester it. So the way we do that is by compressing it into a higher pressure storage with diaphragm, high pressure diaphragm compressors, and keep it in tube trailers and tube storage, better said, fixed ground storage, until nighttime fueling occurs, and then you make it available to the dispensing system, as well as the, you know, in the 8 hours during fueling, you're continuing to again produce that hydrogen gas, and you're compressing it and also introducing it into the dispensing system. So that and what the takeaway from that is that you will often have again, depending upon how many buses you're fueling, how big your program is, you can have dozens, or even in some analysis we've done hundreds of fixed tubes of ground storage necessary to accumulate and store the gas that you're producing overnight. And when I say hundreds, that's for like a 200 bus facility at a very large application. But, you know, so it is a bit of an asterisk. It's something that needs to be accounted for is what you're going to do with that gas that has to be produced during the day and be made available for the nighttime fueling. Electrolysis is somewhat similar in the sense that you're producing a gas that comes off a little higher pressure, 400 psi from the output of an electrolysis skid instead of 200 psi. But you know, breaking down water using DC electric current driven into demineralized water, and you get byproduct oxygen gas, and then your target hydrogen gas comes off. You accumulate that, compress it in the same way that I talked about for the SMR system. So, you know, those are the kind of the liquefied solution on-site production from either SMR natural gas or on-site production from water electrolysis. Those are kind of the forks in the road that you have in terms of how you're going to obtain your hydrogen for the fueling. And then to close out, I've got just some quick yeah, actually, let me flip through here. So we talked a little bit about SMR. Here is a simplified process diagram. I borrowed some slides we recently prepared for TriMet in Portland, showing just, you know, feedstock from renewable natural gas, adding heat and steam. You get the CO shift, and with the pressure PSA separation, you get your hydrogen gas. kind of a simplified solution there, what's going on. This is a skid that Linde manufactures. It's quite large. This is a big skid. This will make 500 normal cubic meters an hour. So it's a pretty large skid, but it would be suitable for the type of facility that would be needed for a bus transit facility. Next is similar process diagramming for the electrolysis system, DC power rectifier here, electrolysis process, oxygen generation from byproduct, and your hydrogen gas dried and separated, and storage, and off to the fueling system. In terms of what they look like, this is what an electrolysis skid from Nell would look like. This side here, this is the DC inverter system making the DC power, cooling tower above, and then on the other side of the skid is the process system that is actually generating the hydrogen gas. So that's kind of what the system looks like. When you're talking about the compression side, and you're coming off at either 200 or 400 psi, then you need to get it up to that 6,000 psi target pressure. This is a large diaphragm type compressor. Diaphragm compressors are quite effective at, purity is very important in fuel cells. Thomas will tell you that we're talking about 4 or 5 nines, 99.999% pure hydrogen is necessary to prevent accumulation of contaminants in the fuel cell. So diaphragm compressor isolates the work side of the compression from the process side, and that's basically what you see here is very large diaphragms. And you would have multiples of these, again, depending upon how many units and how big your system is. You might have 2 or 3 of these large diaphragm compressor skids as part of the system. So pros and cons, and why each one of those types of systems might be better than the other to close out here. The liquefied system is going to be the lowest CapEx on a per flow rate basis. If you analyze flow rate by dollars, it's going to have the best metric of the other systems. Similarly, it's a smaller system. When you start to get, laying out multiple skids for generating product, as well as then the compression that needs to happen downstream of that, compared to the relatively compact liquefied system. This right here, this is about this is about 40 feet by 85 feet roughly. So it's not particularly large, and is fairly space efficient. Let's see, and it's a known quantity. I mean, this is the tried and true technology, the liquefied approach. There are all the industrial gas companies have been developing, and installing pressurized cryogenic liquid systems for decades, and this is not new technology. So it's very straightforward to implement, and you're going to find many takers that will and would be interested in providing that type of work. On the SMR system, one of the big benefits there, we talked briefly a few minutes ago about how green it can be, how easily it can be made green simply by introducing a renewable feedstock from landfill or wastewater digester, etc. It's also very inexpensive to produce natural gas from an SMR system compared to a typical liquefied system. You do have the uniqueness in Ontario of lots of local production, which is great. But that's, for others outside of Ontario, where you might have to truck the liquefied hydrogen, you might be paying in US dollars anyway, somewhere $7, $8, $9 a kilogram. Comparatively, you can produce hydrogen ready to compress and dispense into the bus, for less than $2 US. Probably $2 Canadian, something like that, would be what a cost to get a kilogram of hydrogen dispensed into a bus. And that includes the commodity, electrical energy, maintenance component, all of that, all of the variable costs. It's very cost effective to produce it yourself, to sort of roll your own, as it were. those also low power. With an electrolysis system, you've got megawatts worth of power necessary. You only need a few kilowatts of electrical power for SMR. And lastly, on the electrolysis system, it can be also made green, as mentioned, by just simply introducing green electrical power. You don't need natural gas. You're only using deionized water and a whole bunch of electrical power. And it's very cost effective where you've got, of course, low cost electrical power. So that's kind of the walkthrough, the 101 on the different flavors of on-site management and development of hydrogen infrastructure. So thanks for indulging me there on my monologue.
So thanks very much. That's really been very helpful in sort of giving an overview of what it looks like. And so it seems to me that you've got somebody, an Ontario transit agency looking to put in a system. They have the option of going to a simple system like this as they get underway, using that liquid to ramp their capacity. And by the way, these systems, it's got the big Air Products logo on the side of it. These are typically owned. The equipment is owned and maintained by the supplier. So that's something which doesn't require, I'm assuming, the capital input from the transit agency.
Well, I mean, I think that's, pay me now or pay me later. I mean, right, they may not need to write the check up front, but the cost is in there at some point. And
right, and then so as they move forward, the opportunity then I'm taking what you're saying is that you can look at lowering your cost by implementing on-site generation as your volumes build, and there's your opportunity to lower your hydrogen costs.
I'd like to interject. Okay, so we've had this conversation, but what it does highlight is the complexity of having a robust system. We haven't looked at how to include backup systems and include backup supply systems. So yes, this is the 101. I'm not a big proponent of small SMR units, but purely because of the complexity of running these things. And of course, you have to have the biogas. And there's a whole bunch of other BOP, balance of plant issues that have to be looked at. The electrolyzers have their own pros and cons. But what I'm trying to highlight here is that each one of these municipalities or transit systems will have to look at what is best for them. If they're located to a biogas supply system, great, then they have to look at supplying of that plus backup systems for that, and then dealing with the hydrogen production. Usually those are not really operated by industrial gas companies because they're too small, but there are others that will do it for them, or they could run it themselves. I'm not going to take over the conversation, but I do want to highlight that there is complexity along the whole system, and it has to be looked at and sparsed out correctly, and the criteria to make decisions has to be known, and or we can help to know those criteria so that the best possible decisions are made. But we don't want to make it look overly complex, but we also need to acknowledge that it is something that the utility has to undertake. And if it doesn't want to undertake it, then somebody else has to be paid for doing that, whether it's an industrial gas company or another company. That has to be paid. Somehow that has to be put into the value chain.
I'll reiterate what Pietro just said. There's forks in the road, and the angles of those forks are quite wide, if I may say. So, making those right decisions early on are important, and getting that analysis before you start going left, right, or center is important. So yeah, you really do need to understand what you're trying to achieve over the long term and making the right. But as Mark said, there is an opportunity perhaps to do a sort of a blended system. In fact, that is actually something that can work well, is to hedge resiliency by having a combination liquefied and on-site production system, whether it be SMR or electrolysis. And that way you have resiliency, redundancy, and yeah, you might not in some interruption, whether it be power or delivery or whatever it is, you may not be at 100%, but you would be able to have at least some availability of fuel if you have a blended system. So that's something else that is very much on the table.
Okay, so summarizing, there are systems available. There's a range of them. Retain a good, knowledgeable consultant to help you in assessing the options. And but again, there are solutions that are available. But I want to hark back to something that David had mentioned. You know, we talk about the fact that there's hydrogen being used in other areas, in other sectors. You know, why can't I just get hydrogen as a pipeline? Why can't I just hook up to my hydrogen utility? Is that something that's a realistic future opportunity? I know, you know, either from a hub or going forward. David, can you comment on that?
Good thing, Mark. Yeah. So, you know, the direct hydrogen pipelines today are few and far between. I think a future state when we look towards net zero, that certainly will become a reality. In the near term, where there's opportunity to co-locate production of green hydrogen, low carbon hydrogen near demand, where there's industrial demand, you're likely to have a pipeline, you will have a pipeline between the demand and supply. And so where there's an opportunity to tie into that for transit purposes in a future state, yeah, certainly we see that as a great opportunity that would help to eliminate some of the intricacies. So in terms of time frame, you know, I think early projects where we're trying to set up hubs is going to happen in the next few to 5 years. And then the pipeline infrastructure really, I think, grows out of those hubs as they're developed and as we start to see more demand, more uptake for hydrogen as different industries are trying to make those net zero commitments that they're all setting out to right now.
And I'll take the opportunity to plug a little bit about what we're doing. And this under the National Hydrogen Strategy for Canada, there is a hubs working group that the CHFCA is leading, and we're engaging with people right across the country to see where we can actually start getting those hubs in place. Where do you have the concentrations of industry, of transportation needs around ports, around transportation corridors, around industrial processing centers, you know, places like Sarnia, like Edmonton, like Montreal East, and Vancouver Harbor, et cetera, where we can do that, where we can start in the next relatively near term, putting in that supply and starting to hook up customers by pipeline. So yeah, that's my encouragement to everybody involved here to get involved in some of the work that's being done nationally, because it will be, I think, a strong benefit to municipalities to see that move forward. But in the meantime, there are viable solutions. It's from the sounds of it, and but you do need to get that support from a qualified consultant.
Great to call out there, Mark, and I'd just like to compliment your leadership in making those hubs happen. What you see is multiple industries coming together, people who normally wouldn't necessarily talk, saying, you have a need for hydrogen, I can make hydrogen, I have green electricity, and you see that happening. So anyone on the call who has an interest in seeing where are those hubs, reach out to Mark, reach out to myself, and we can point you in the right direction. But Mark, you're doing a great job with that.
Thank you.
And just like to add, to add to what David and Mark is saying, and there's another hub sometimes we don't think of, and that's the Bécancour hub. That's brand new. We don't normally think about that, but that's growing actually, purely because of the startup of hydroelectricity and the liquid hydrogen that's being produced, but it's creating industries around it. They're already there, but it's also creating new ones. So they are starting, where it's embryonic, but they are starting.
Okay. All right. So that's kind of gone through the whole process.
Sorry, one comment there, Mark. So it looks like you got hydrogen on site. So what do you do about the bus? How do you fill the bus? So I just got a couple slides here. This is the tank system that is on both 40-foot and 60-foot vehicle. So it's really like a CNG. There's not a diesel, like a CNG. You basically just plug in the source into one of the receptacles, depending on what type of receptacle you have. One of the key things here is when you're filling, it's warm, so it's actually at a higher pressure. So when you get to the tank pressure, it kicks out, unless you can overfill a little bit, because when it'll cool down, it'll actually be at a full state. Whereas if you fill it to the peak pressure, then it cools down, you won't have quite a full fill. So this is where communication with the station is important. And then here's just a couple of shots of sunline of a typical station that they have there plugged in. So yeah, that's pretty much what it is at the bus level.
Thanks very much, Thomas. Appreciate that. That gives a good idea of what the filling pumps look like. And by the way, looks quite similar to the hydrogen filling pump I have down the street from me. About 3 blocks away from me, there's an Esso station that has a hydrogen filling station at it, and it's that's a pump right in with all the other gas pumps, and people pull up and they fill their gasoline vehicles or they fill their hydrogen vehicles right next to each other. And by the way, it doesn't cause any sort of concern or issues with the public, and it's been operating there for over a year now without any issues. So I think it's certainly hydrogen is going to become more and more common. We're going to see it in more and more places. So at this point, I'd like to turn it over and let sort of concluding remarks from people today. But well, before I do that, though, I would like to open it up to questions from some of the members. And do we have Karen? Do we have time for getting some questions in from members?
Absolutely. We're going till 1:30.
All right, good. So there's a chat window here, and I would I'll just have my first look at it. Oh, there's quite a number of them coming here. All right,
I'll help you out, Mark. The first question was about cost. In the short term and long term with contracts and uncertainty. It seems to be a key challenge. How can this be addressed?
Okay, I'll turn that one over to Pietro. Do you want to start with the cost question for hydrogen? And I'll
yes, thank you. So we talked a bit about on-site production and the two methods. We talked about liquid hydrogen. We talked about gaseous hydrogen. They all have different pricing structures, and they all have a need to be looked at from the robustness as well. You have to add that as well, and all the factor inputs. So, you know, to say what a price is going to be is very difficult, because it's all based on volume, it's all based on frequency of use, and it's also based on how you produce it. Not to say this, but Stantec can help you get to the best solution and the best possible price and $1 per kilogram. And also maybe into phasing it, whether it starts with gaseous because it's the easiest way, and as you grow and use, you may want to look at liquid, and if that's too much, then you may also be looking at comparing it to electrolysis or others. But what's also important is that you need to look at this not only from the best technical solution, but best commercial solutions, and having the right arguments against your potential suppliers, so that they are competing against you in a supply mode in the best possible normalized way, is also something that is of importance to the municipality, to the fleet operator. So it has to understand how to leverage the best possible arguments so that it gets the best possible price. Finally, all of these technologies, all of these transport, all of these logistics are all going through a lot of disruption. They're all being looked at in ways that can be more competitive. The electrolysis industry is doing that, both for manufacturing the electrolysis units and to be more competitive. The logistics people are trying to, within the industrial gas suppliers, are also looking at being the best possible, lowest possible cost. So it is a moving target. And all I can say is that there's a responsibility for the municipality, for the fleet operator, to always be at the edge of understanding, and we could help with that, but to be at the edge of understanding so that it gets the best possible price for a commercial time frame, whether it's 5 years, 10 years, 3 years, 7 years, whatever it is, but it has the best possible solution at that time. So I really don't want to give dollars per kilogram, because that's always going to be right and it's always going to be wrong.
Yeah, I'd agree with Pietro, and I would just say that, as we look forward, particularly in the electrolysis produced hydrogen, the cost of the equipment is just going to come down because of the scale at which electrolysis is going to be deployed globally as the hydrogen economy takes off. So, when it comes to the cost of the electrolyzer capex, we expect a high learning rate, similar to what we've seen in solar panels. Used to be very expensive. Prices come down significantly with wide scale adoption and processes in the manufacturing. And so, yeah, fully agree with Pietro. It's hard to give a dollar per kilogram, and I would endorse talking to Stantec about what the options are for hydrogen production. We think that electrolysis produced renewable hydrogen is going to be cost competitive in Ontario, particularly as we're going to be close to the needs. But Pietro's right on, and Stantec's a great company to work with to say what are the options.
Mark, I will pick up one other question in the chat then before we leave costing. A question about how does distance to source affect the cost of hydrogen?
Pietro, I want to turn that you got sort of a lot of experience in that one.
Yes, you have to minimize it, period. What's nice about Ontario, though, is probably the densest possible area of Canada, right? So there are economies of scale and distribution. And so whomever wants to produce that hydrogen, liquid or gaseous in a certain area has the economies of scale of distribution. The logistics are going to be better. So it's not only distance, but also the ability to make rounds and to be within a dense area. But definitely you have to minimize it as much as possible. And then choosing the right mode. Is it gaseous or is it liquid? And is it available or is it not available? But yeah, we could help you decide what you're willing to pay per kilometer of hydrogen supply, because that's going to be essentially one of the biggest costs.
All right. And I will say that from what we're seeing around North America, and others may want to comment on this too, is that in response to the demand for forklifts, for light duty vehicles in California, we've seen a doubling in the capacity of liquid hydrogen in North America over the past couple of years. There's been new plants put into Texas, there's been a major expansion in Quebec. There's a new plant under construction in Las Vegas, and then recently announced a project in Edmonton. So I think what we also are going to see is a substantial, and by the way, there's others that are being talked about right across the country. So I think that what you're seeing is a real excitement on the part of the suppliers that this market's coming, and they're starting to put in place that capacity to meet that. And I think you'll see that continuing as well. Go ahead.
I just wanted to add that the suppliers are also very smart. They're going to be putting these sites in areas that are the best possible logistics in reducing that logistical cost and getting the best possible factor inputs and having the biggest access to markets. So they're going to be very smart as to where they're going to put it. But as you said, there are a few that are studying a lot more plants all across North America. So it's coming as well. I know I've said it before, but it's true.
Yeah, but we'll go back to this. So this question of cost, because I don't want to let people off hook that easily. So in California, they've got systems going out. I mean, how are they seeing the cost for hydrogen developing in that market where you do have also, there's certainly a shortage of liquid right now, but there are companies that are operating today. What are they seeing in terms of their costs as they move forward?
Reb, you're there. Do you have any comments on that?
That was to me?
Yeah, that was to you, Reb.
Sorry, Mark, I didn't quite follow the question. Could you please repeat that?
Well, you've had experience down in California where transit agencies, and in Ohio where transit agencies are actually running now with their hydrogen supply systems. How are they seeing their costs coming together as compared to diesel costs?
I don't have comparative metrics on that handy.
Right.
I think that it's difficult to measure that because the few hydrogen facilities that are here, they're blending their maintenance cost with the commodity cost, so it's not completely transparent on how those costs, can be assigned to commodity versus maintenance. So I'm sorry, I don't have good info on that.
All right. Anybody able to comment on some of that? I know New Flyer has any experience on there. Tough one. Okay, we'll leave you guys off the hook for that one, but I think it's.
That is a tough one. I agree. Yeah.
If it's open to the audience, this is Jamie Levin from CT. I can certainly comment on that.
Is that okay? Sure. Go ahead.
Yeah. So we're looking at liquid supplies at somewhere in the $7.50 to $8 delivered per kilogram delivered. I think what we have to realize is what the previous panel and the speaker spoke to is that we've got to see volumes, much higher volumes, but there's clearly growing interest. We're seeing the tipping point here. Demand is increasing, and one of the challenges we've got is upstream supply and renewable supply. Air Liquide is soon going to open up their liquefaction plant in Las Vegas. That's going to bring a third source of liquid supply to the California market. And then there's talk about Plug Power opening up a production facility. So prices are still high. They net out at around $8.05, $8.10 at the AC Transit Orange County stations per kilogram. That's still high compared to battery electric or diesel, even with the great fuel economy from the buses. Good news is buses are doing really well. New Flyer has performed superbly. We're seeing great fuel economy, great range. Transit agencies want to see this. Truck operators, fleet operators, but we've got to ramp up the fuel supply. Thank you.
So
Thanks very
that's
much.
the
I really
point.
appreciate it, Jamie. Jamie, you just wanted to say a quick who you're with and what's your background?
Yeah, I'm with the Center for Transportation and the Environment. We're a nonprofit. I'm based in Berkeley. We're managing a lot of different projects, both fuel cell buses at AC Transit Orange County, Golden Empire, Foothill Transit soon to launch it did last week, its RFP for the next fueling station, North County Transit in San Diego. And we're also involved in fuel cell trucks. We won a big award to launch Class 8 fuel cell trucks at a fairly significant scale in North America. And we're just excited about it. And Thomas is on the call, and hats off to New Flyer. They've designed a superb vehicle. And I don't know if this was touched on, but I think you raised it, Mark, about resiliency. Keep in mind that a 40-foot bus, the New Flyer bus, has 600 kilowatt hours of usable energy on it. And the 60-foot Arctic has over a megawatt hour of usable energy. And we see in the future the ability to upgrade the inverters on those vehicles to be able to provide exportable power in natural disasters, and the ability to refuel. The 40-foot bus refuels in 6 to 10 minutes, and the 60-foot bus within 15 minutes. So it's going to open up great opportunities as we transition to zero emission. So it's very, we're looking at the opportunities. There's a positive future.
Thanks very much, Jamie. Pietro.
Yeah, I'd like to add the way it was answered by Jamie. You know, we shouldn't just focus on $1 per kilogram issue. You know, there is going to be a delta by any fleet operator, by any municipality, that they're going to have higher costs, whether it's electric or hydrogen. In this case, we're talking about hydrogen, but it's the total cost of operating those buses relative to the alternative of having diesel and complying or not complying with whatever regulations are being imposed. So you have to look at supply, you have to look at the maintenance, you have to look at the ridership, you have to look at the buses. And then, you know, I think what a customer in the end wants to see is what does it cost me to provide this service to my customers on a per kilometer basis. And so the hydrogen definitely is a big component of it, but then we also have to look at it in terms of the whole system from getting this hydrogen all the way to supplying the service. There is going to be a delta, but can I live with that delta? And at the moment that delta exists, but you know, as David said, the prices are going to come down for a bunch of reasons. We're not going to go all into that, but it has to be looked upon holistically, not from the supply side and the dollars per kilogram, but all the way to supplying the service.
I have to add one comment. Pietro's right on. It's about operational efficiency. And what the fuel cell technology and hydrogen provide is a replication of what fleets are used to with CNG and diesel. And there are definite cost advantages over the life of the vehicle, the life of the fueling infrastructure. Keep in mind, operational efficiency, that's what's key here.
Okay. Thanks very much. David, Thomas, Reb, anything you guys want to add on that point?
I don't think you could say it
Agreed.
clearer than Jamie. That was great.
That was great. Thanks very much, JB. And I will also state from that is recognized now by the federal and government that there is that price differential both on the capital equipment and on the fuel. And right now there is probably, as I mentioned in the beginning, more funding available from the federal government than it's unprecedented, and I would encourage people to explore that. We've been having discussions with the Canadian Infrastructure Bank, with Infrastructure Canada, with Natural Resources Canada, and so I think there is very much a willingness over the next few years to find ways to close that gap, both on the capital cost and on the fueling costs. So I would encourage folks to explore this and to start thinking about how they can get some support on this. And I think the doors will be open and there'll be some very good willingness to do that.
Mark, could I assist? We have a few more questions and about 10 minutes left.
Good for it. Yeah, thank you.
Wonderful. There were comments about the 40-foot and 60-foot buses, but we've got a question about paratransit applications. Mark, you were mentioning passenger vehicles fueling up down the street from you. Can you speak to the paratransit market?
The paratransit, I mean, as in disabled
Specialized, smaller vehicles. Yes, the smaller.
Not an expert on that. I don't know if New Flyer, you can comment on that.
Yeah, that's I would say still to come. We do have a smaller vehicle manufacturer, part of our one of our subsidiaries, part of NFI Group, called Arbach, and there's mostly cutaways. Now, are the cutaways available from the OEMs for GM Chrysler in CNG form, or sorry, in hydrogen fuel cell form? Right now, they're just starting to release electric versions, so I think it's going to be a bit of ways from that perspective. We do actually have a smaller medium duty bus that's just being electrified right now, and if the market's there for hydrogen fuel cell, we can start considering it. But one of the challenges with the fuel cell is the amount of equipment you need. Not only do you it's an electric bus, so you need the batteries, you need the power electronics, you need the motor. When you add a fuel cell and you add all the tanks, it starts to become space constraint challenges with respect to that. And even on our 60-foot bus, even though it's 20 feet longer, we don't actually have a lot of real estate to put not only the extra set of tanks, but all the batteries, the 2 strings of batteries are required. So really have to dig into a little more as to what the solution might be. So I would say it's not now, but it's certainly on our radar to investigate further.
And I will talk generally about the whole truck market, the heavy duty, and what's happening. So first of all, from a Canadian perspective, we have probably half a dozen fuel cell developers that are involved with OEMs around the world. So Ballard, Cummins, Unilia, Loop, Looming are all fuel cell developers here in Canada that are working with OEMs around the world to integrate fuel cells into various types of vehicles. There are literally thousands of trucks, lighter trucks on the road now in Asia, and they're working very successfully. There's millions of miles on those trucks. All the major OEMs are now looking at how they can integrate fuel cells into their vehicles. But it's a slow process. It's a major investment, as Thomas has mentioned, to integrate a fuel cell into your product line. So they're looking to see where do they go first. What are the markets that are the ones that they can get some volume, where they can get things happening. I think the nice thing is that buses have gone through that. There are these commercial buses available today, and so it's a leading market. It's an indicator. There's really no reason to think we can't do that in other heavy duty applications, but it's going to take some time for those to come forward. I'm optimistic that we're going to see different trucks coming into the market over the next couple of years. There's a lot of players that are pursuing it, and that by 2030 there will be a wide range of fuel cell electric vehicles available for multiple applications.
Wonderful. I think we've got 3 or 4 more questions. We may have to go to rapid fire soon. So a question about who provides maintenance and repair service for fuel cell in Canada?
Thomas, you want to take that?
From the perspective of the vehicle side and the scope of the supply of those components, New Flyer can provide the maintenance training of all those systems related to regular vehicle systems, but also from the perspective of the power electronics and the propulsion systems. We have sources for that that we can provide that training direct to the customers who do their own maintenance. For the side of the fuel cell and any maintenance there, we currently have Ballard, and they would be able to supply maintenance training for theirs, which we've done in the California properties already, where we've delivered 25. So it's really from that perspective on our own vehicle. We have some maintenance facilities. We have one just outside of Ottawa that in Canada that will be prepped once the technology is being delivered and be able to support that. Other than that, it's typical that transit agencies perform their own maintenance, and we have the training services available through our training department.
I will mention that the Ontario Standards Association is also working on training courses through colleges to get certified hydrogen technicians in place, and also to help transition oil and gas workers, people that are working on natural gas systems today, to transition those, because I mean, it is going to be a key need to develop those skill sets in the hydrogen fuel cell area, and it's one of the challenges we need to be addressing. Anybody else? Good. Any other questions?
Yeah, we'll stick with Thomas then for this one. Someone would like to hear more from New Flyer about availability and pricing for battery dominant fuel cell buses, where the fuel cell is the range extender.
Yeah, we have really the only one solution. It's a fuel cell as a range extender, or it's really the same type of thing. Where you come into it is that the sizes of fuel cells that are available today and right sized for the application. What I mean is, you have a diesel engine for a 40-foot bus that's 280 horsepower, or 330 for a 60-foot bus. Fuel cells don't come that big yet. So fuel cells generally don't like to be throttled up and down like an engine does for engine speed and that sort of thing. You want a more steady state for their operation. So the nice thing is, in a transit application where it's stop and go, is that the batteries really take care of those instantaneous high power demands, and in energy recovery through regenerative braking. The fuel cell basically just runs steady state. It does have a couple of power settings just to maintain some efficiencies, but generally that's how it works. It's the propulsion system is kind of an independent propulsion and batteries from the fuel system, from the fuel cell system, which just keeps replenishing those batteries at more of a steady state. Where you get into the challenges is if you have a high continuous power demand, such as a highway application, where you need that 150 kilowatts to run continuously. We don't have a 150 kilowatt fuel cell. That is something a next step forward in the larger fuel cell arena. That's something that will be more like useful for a truck, continuous on the highway, continuous speed on the highway, going up grades and that sort of thing. And even for a coach, it would be suitable for a coach to have that larger fuel cell. So when on the transit side of things, where you got the stop and go traffic, you can get away with a smaller fuel cell and being able to operate a one-for-one basis in the transit application. It's those corner cases in the transit application where you would need a high power demand that is a little more on the challenging side. So there's really no difference on that. In terms of pricing, I'd given earlier there that we're in the Canadian dollars on the 40-foot bus, you're about in the $1.4+ million range. And as I stated earlier, those are expected to come down as you get volumes and economies of scale.
Mark, I'll turn it back to you. We have 1 minute left. Maybe you can do a wrap up for us.
All right. Well, thank you very much to the panelists. Thank you, Karen, again for the opportunity. Thanks to Stantec for sponsoring this event. I really think it's been a useful to hear from all the speakers. Provided some very good insights into the market. I do encourage, as Pietro said, and it was reinforced by others, if you're interested in this, it is a field you're going to have to spend some time and do some investigation, engage a qualified consultant or to engineering firm to assist you in that work. But it's worth it. It's something that should be considered as part of your fleet. And with that, I will say thanks very much. And if there's any questions, please, that follow-up questions, please do contact us. Hopefully our emails are available, or you can have things forwarded through Opta. Thanks again, and best to everybody out there.
Thank you, Mark. We've been requested for the slides that were used today, so everyone will hear from us. So thank you for joining. Take care.
Thank you so much.
Thank you.